Now let's go to the last part, graph of inverse function. So we should know that the graph of f inverse is obtained from reflecting the graph of fx in the line of y equal to x. Okay, meaning that you can just draw the graph of fx, and then to find f inverse x, we just reflect the graph about the line y equal to x. So you can see this clearly throughout this question down here. Sketch the graph of fx equal to x squared minus 3, where your x is more or equal to 0, and also gx is square root x plus 3. So let's draw both of them on the same axis. So let's draw the first one here, x squared minus 3. This is a smiley graph, okay, but just the right part. And then from the smiley graph, you need to shift down by 3 units. So from here, from a smiley graph, let's shift down by 3 units. So label the graph fx equal to x squared minus 3. So this is the new point right now, 0 minus 3. Now let's graph another graph here, gx. This is a square root function. So you know a square root function, the shape is like this, okay? And then you have minus 3 inside, meaning that the transformation is shift left by 3 units. Okay, so just follow the shape, shift left, and then this is your new graph. So since you have shift left by 3 units, from 0, 0, now this coordinate here is minus 3, 0. So now we can see that f and g are inverses to each other because the graph here is reflecting about the line of y equal to x. It is as if you have a mirror here. Now let's see the domain for your fx. So it is starting from 0 up until infinity. So 0 included until infinity. And then let's see the range for your fx. So starting from here, minus 3 included until infinity. Now let's see the domain for your gx. Okay, so this is your gx. Domain is from here, minus 3 included until infinity. And your range is from here going upward. So from 0 included until infinity. So can you see that the domain and range are interchangeable between each other? So we can conclude here the domain of fx is the same with the range of f inverse. Okay, I've written here. And another one, the range of f is equal to domain of f inverse. Now let's see the next graph. Find the inverse function of fx equal to square root of x minus 2. Hence, sketch the graph of f and f inverse. So now let's find the f inverse. Let y as equal to square root of x minus 2. And then square both sides to get rid of the square root. So you're left with y squared equal to x minus 2. So now let's make this x here to be your subject. Okay, so x is equal to y squared plus 2. So let's conclude our answer. F inverse x is equal to x squared plus 2. But now your x must be more or equal to 0. Why? Because you are given here your fx is a positive function. So now let's graph both of them. So you can just graph one and another one will just follow. So in order to graph them, you can just sketch the graph of fx, and then to find f inverse, you just reflect about the line y equal to x. So let's try. This is the basic function, is square root of x, and then minus 2 inside, meaning that you are shifting to the right by 2 units. So originally, this is the graph, but now you have shifted to the right by 2 units. So the new coordinate is 2, 0. If you give another one, from 1, 1, now this is 3, 1. So let us just reflect it about this line of y equal to x. The coordinate will be exchangeable. So from 2, 0, the new coordinate will be 0, 2. From 3, 1, the new coordinate will be 1, 3. So just reflect it towards this mirror. So this is the new shape of the graph of F inverse. You can also check the graph of F inverse. This is just a smiley graph, but only the right part. And then you just shift up by 2 units. So originally, this is here. Okay, a smiley graph, but only on the right part. And then we just bring it up by 2 units. So you'll get the same graph as if you are drawing. Okay, but you can also just reflect it about y equal to x. So now let's read the domain and range, but let's use the properties. So domain of F is the same with range of F inverse, and the domain of F inverse is the same with range of F. So let's read from your function F. Domain for F starting from 2 included until infinity. And the range for this function F here, you are starting from 0 included until infinity. So just read the domain and range from your F, and the domain and range from your F inverse will just follow. Now let's see the final example that I will give you. Find the inverse function of fx equal to 1 minus 3 x plus 2 squared, where your x must be more or equal to minus 2. Hence, sketch the graph of both f and also f inverse. So first step, let us calculate what is our inverse function. So now let y as equal to 1 minus 3 x plus 2 squared. So bring this over here, y over here. So you're left with this term. This is 3. Let's divide 3 here, down here. And then when you want to open a square function, what you should do is you need to make sure you put the plus minus sign. So this is plus minus sign of square root 1 minus y over 3. But in order to choose whether you want plus or minus, it depends on our condition. X must be more or equal to minus 2. Since x must be more or equal to minus 2, this value here will be always positive. So let's choose a positive sign here. Finally, let's bring 2 to another side. So this is minus 2. Therefore, let's conclude our answer. F inverse x is equal to square root 1 minus x over 3 minus 2. So now let us sketch both f and f inverse. Let's start to sketch fx first. So let us see what is happening here. Okay, so the basic graph is fx equal to x squared. And then what you're doing here, the first transformation here is shift left, comma 2. Next, the second transformation is you have minus outside. So if you have minus outside, meaning that this transformation here is reflect about x exit. Next, you have 3 multiply outside of your function, meaning that this is the third transformation, which is stretch vertically by factor c equal to 3. So 3 is more than 1, that's why this is stretch. So what you're doing after this, y coordinate should be multiplied 3. And finally, you have plus 1, meaning that the final graph is shift up, comma 1. So this is the basic graph. This is a smiley graph with only the positive side. So 0, 0, and then you have 1, 1. So now let's shift to the left by 2 units. So the new coordinate will be minus 2, 0, and then this will be minus 1, 1. Next, let us do the second transformation. Reflect about x-axis. So these points stay the same, minus 2, 0. However, this point here from minus 1, 1, now it will become minus 1, minus 1. Now let's go to the third transformation, which is stretch vertically by factor c equal to 3. So what we should do is y-coordinate multiplies. So let's take the y-coordinate here. 0 times 3 is still 0. Take the y-coordinate here. So minus 1 times 3, this will be equal to minus 3. And then let's go to the final transformation, shift up by 1 unit. Okay, so the final graph is here, shift up by 1 unit. So the coordinate here will be minus 2, 1. Another coordinate will be minus 1, minus 2. So now let's transfer this graph here in this axis here. So this is the graph. This point here is minus 2, 1, and then this point here should be minus 1, minus 2. So this is the graph of fx. So in order to graph for f inverse x, let us just reflect this graph along this line of y equal to x. So let us find the coordinate first. So just flip this coordinate, interchange it from minus to 1. Now it is 1 minus 2. And another one, let's just flip this graph. Minus 1 minus 2, it should be minus 2 minus 1. So let us just continue this point together. So this is your new graph of f inverse x. So you can always retake the coordinate whether this is correct or not. So you can check when x is minus 2. 1 minus minus 2 is 3. 3 divided by 3 is 1. Square root of 1 is 1. Minus 2, it is minus 1. So you get the same point. How about this point here? 1 minus 2. When x is 1, 1 minus 1 is 0. So this is 0. Square root of 0 is 0. And 0 minus 2 is minus 2. So you also get the same point here. Now let's see the domain and also the range. So the domain of f is just the same with the range of f inverse. And the range of f is just the same with domain of f inverse. So let's read the domain for f first. So focus on this coordinate of f. Let's focus on this green line of fx here. So the graph is starting from here, x equal to minus 2. So the domain is minus 2 included until infinity. Therefore, this is the same case for range of f inverse. So the range for this line here is started from minus infinity, and then this is axis until this point here. So until y equal to 1. So the range is from minus infinity until 1 included. So this is also applies for domain of f inverse. So that's the end of this topic. Assalamualaikum warahmatullahi wabarakatuh.